All right, so we have the directions to use the line that's graphed to create 3 different slope triangles and give the rise over run for each one. Be sure to simplify all answers. Okay, so we are going to use 3 different colors to represent this. Go ahead and start with green. Notice that on this line, there aren't any ordered pairs that are already labeled. We're going to label them ourselves. You're looking for whole number values. That are going exactly through the grid on that line. We're just going to start with the ordered pair -8, 8. So if you start at the origin, -8 is backwards 8. And then +8 is up 8. And you see it's going to be right on the tip of that arrow. So that is ordered pair -8, 8. Okay, and we are going to count the rise and run to another point on the graph. Another whole value point would be the intercept. Where's the intercept located? Use your words. It's at 0, -4. So it's at 0, -4 is the y-intercept. Okay, now we need to count the rise and run. First, just at a glance looking at this and thinking about that slope dude video, is this a positive or negative slope? It is negative. Okay, it's going downward over time. Okay, so how far down do I need to travel before I start to turn right to go to this point? Okay, let's see. This is 8 for sure. So 8, 9, 10, 11, 12. So I had to go down 12. To show that I went down 12, write -12 next to it. And then how far to the right do I need to travel? How far is this? 8. Too much talking for those that don't understand. Okay, so shade this triangle in light green. What type of triangle is this that's formed? How do we know it's a right triangle? Has that 90-degree angle there. You have the 2 legs, which are the rise and the run, and then you have this diagonal. Does anybody know the name of the diagonal? It has a word for it. The diagonal on a right triangle is called a hypotenuse. Yes. Okay, so triangle 1, the rise was -12 and the run was 8. Simplify that fraction. Reduce that fraction to smallest terms. What's -12 over 8? No, it's not 3/4. -3 over 2. And what was that decimal you found? -1.5. Okay, so the fraction reduced is -3/2, but the decimal is -1.5. All right, let's talk about a second triangle. So you can put that green pencil down and grab your red pencil. Let's go to the ordered pair -4, +2, and put a point. -4, +2. Okay, so place a point at -4, 2. And then I want you to place a point at +2, -7. Find the rise and run of those from those 2 points. What is this vertical movement? How far do I have to go down? It's not 8. It's 9. Guys, we need to quit talking so much and start focusing. I'm going to start calling out names. You're going to have to bring your glasses. All right, so this is down 1, 2, 3, 4, 5, 6, 7, 8, 9. This is down 9. So what represents down 9? How do I write that? Negative 9. And then how far over? Over 6. Okay, and that is a new triangle, right? Okay, so shade that one in lightly to show that they overlap, that we did actually create a whole different triangle. Are they the same size?
No.
No, we have one that's 12 by 8, and then we have another one that's 9 by 6. And okay, so triangle 2 over here on the side, we need to write that it's negative 9 over 6. Simplify that fraction for me. Reduce it. It's negative 3 over 2. And what does that mean the decimal is? So are the slopes the same on these 2 triangles? Okay. Let's create a third triangle. Okay, so put your red down, pick up your blue. All right, we are going to create our third triangle. Put a point at negative 2, negative 1. Right here. Negative 2, negative 1. And then you're going to connect it. We're going to reuse the y-intercept. We're going to reuse the y-intercept. So how far down do we have to travel?
3. Oh, yeah, 4.
You guys are so easily persuaded. How far down do you have to travel?
3.
It is 3. How far over? 2. So down 3 over 2. Is that the simplified version?
No.
Yes. Negative 3 over 2 is as small as it's going to get. What is the decimal? What do you notice about all 3 triangles that we created? They have the same slope. Are they the same size? No. But they all have the same slope. Why do they all have the same slope? They're all created by the same line, right? All right. And what do you notice about the different fractions here that we got originally? They're all negative. They all simplify to the same reduced fraction, which means that they are all what we call similar triangles. Okay? So now, the slope of the line, we're going to leave it in fraction form. It's negative 3 over 2. Now, if I were writing the equation in slope-intercept form, y equals mx plus b, what is the m? What is m? Negative 1.5, which is negative 3 halves, right? What is b? What is the slope? What is the intercept? What is it? Negative 4. So if you were writing the equation for this, it would be y equals negative 3 halves x minus 4, because it's negative 4.